So today I'm going to be talking about using enabling technology to support STEM students with learning differences and disabilities. I put my hand up at this point and say I'm a lapsed STEM student stroke professional. I did study meteorology at university and even at PhD, and I was also dyslexic. So partly my experience and interest in this area is from my own background. So first of all, I wanted to just sort of start off with thinking about what do we mean by learning differences and disabilities, and consider exactly how they might impact somebody who is learning and working towards a profession within science, technology, engineering, maths, medicine, and similar fields. So first of all, it's always worth considering with students who have learning differences or disabilities. Sometimes they're also now referred to as neurodiverse students, that whatever their label they may have, their disabilities often overlap. And this is a wonderful diagram that was developed by Mary Coley showing just how complex the use of those labels can actually result in when we look in the types of difficulties that those students have. But when we're considering what does that mean within a STEM field, there are a number of core skills that need to be used within those fields that can be impaired and impacted by people and students with learning differences. And one of the key ones actually is time management and organisation. There's a lot of information, a lot of facts, and a lot of activities, often that are quite process-driven, that you have to do within a science and technology field. So time management and organisation can be a core skill that needs to be developed and supported. There's also note-taking and multitasking, and we'll look a bit about some of the activities that students have to do where that can be impacted. Reading accuracy and speed, not just sort of reading proficiency, but also actually are they accurately identifying numbers, identifying symbols, identifying diagrams, and sometimes under situations where they're having to multitask. We also have to think about the special terminology and symbols that are often used within STEM fields and how that can be difficult for some students to learn and to recall and to write as well. Then we have the added effect in STEM areas of scientific notation. How do you read that? How do you transcribe that? And that is often where we're up against the limitations of what assistive technologies and general technologies can now do. And then also within STEM fields, there's often a factor within qualifications and training that students are required to work in groups and deliver presentations, and that's becoming an increasing factor within qualifications as employers look for students to develop those skills. And that can be difficult for students who have communication or social difficulties, who find that developing those skills can be particularly hard. So in the title we also included disabilities, and I wanted to just highlight a few areas where we have to consider the needs of those who may have physical or sensory related disabilities, and we'll touch on those as we go through the slides. So one of the core ones is accessing information, particularly if there's a sensory difficulty. A lot of information and teaching materials are now being delivered as video. That can be difficult for both those who have visual impairment and hearing impairment. We need to think about audio describing videos. We need to think about transcripts and captions for those with hearing impairments. Handling equipment is something that often is considered a bigger barrier for those with physical needs, but careful planning and risk assessments can also often result in alternative arrangements for adapting equipment, experiments and activities for those with additional needs. We'll touch on involvement with fieldwork and work placements can often seem like a barrier for those with sensory and physical needs. And again, often people raise concerns about safety considerations and risk assessments. But in the whole, careful planning and consideration of students' needs at the onset of qualifications and courses can overcome many of these difficulties. So let's think a bit about the student experience in science, technology, engineering and maths, and why it can be different to those studying in other subjects. I'm aware that many of you attending this webinar are from different educational backgrounds, from vocational, further training through to those in higher education as well. But there are some unique factors that we find in all those levels of STEM learning. The first one is the classroom situation. Now, there's an image there on the screen of a lecture room, and that might not be so familiar for those of you in further education, but that's an extreme example of what we end up with teaching in STEM fields. It's often this talk and chalk approach still, and even when we're in a more relaxed, smaller classroom environment, often when you're delivering STEM teaching materials, we're having to deliver abstract information, and that often requires going through problems and scenarios via presentation materials or through whiteboards and blackboards, and students have to capture a lot of that information and understand it in quite a formal situation. The other unique aspect with STEM fields is the lab environment, and often when we think of labs we think of the image in the top left-hand corner where we have those taking science experiments, and yes, that's still the case in schools and colleges in particular fields, and it's also the situation in some professional environments as well. But we also have to think about the lab environment for those who are studying more practical subjects, particularly the medical fields, where they may be having to interact with their peers and doing scenario-based training, such as we see in the top right-hand corner with some physiotherapy students. We may have more electronics-based and computing-based scenarios as well, as we see at the bottom. And these environments are often cramped. They can be quite disorienting to those who can struggle with different physical environments, and they do require some sort of social interaction with other peers. So often the lab environment can be challenging for those who are unfamiliar with that type of learning scenario. Always in these situations there's also an element of multitasking. Students are being asked to do a physical activity or a computer-based activity, take notes, make sure they're capturing what they're experiencing, and then they are often assessed and evaluated on the material that they output either during the session or written up at the end. And that is particularly challenging for those who have time management and difficulties with writing and reading in a time-pressured scenario. Then the other aspect of STEM learning and professional is often field work and work placement. And that can vary from going out onto a mountain, going to an archaeological dig, as I experienced it as a student, going outside and looking at clouds and taking rainfall measurements, or it could be a more structured work placement or even apprenticeship situation where students are going out into the workplace and having to interact in a professional environment and use equipment and such like. And that's something that has to be, again, carefully planned, taking into account risk assessments, but it is possible to remove many of the barriers for those students. So, moving on to some of the technology solutions, and limited time today, so we're just going to touch on a few of the key factors to think about really and point towards a few tools. The first thing, really, I wanted to highlight is portability. Mobile phones, laptops with small devices and tablet devices have made a huge difference to everybody's experience, both professionally and as learners. And if we think back to those different environments that our students in STEM have to experience, whether it's fieldwork or lab, portability is key. And now we can remove quite a lot of the barriers if we just think a bit more smartly about how we use those portable devices. So one of the tools I wanted to talk about first is one many of you may be familiar with, but I wanted to look a bit at some of the ways it can be used. And this is Microsoft OneNote, and its partnership app Office Lens, which is now available free on Android, Windows and iOS devices. And Microsoft OneNote has been around for many, many years, and Microsoft keep putting tools into it. And I've done some studies with students who were using it within an engineering situation. We were asking them to trial it when we had the first types of tablet PCs. And it demonstrates how actually a good structured note-taking app can make quite a big difference to those students who have reading and writing type difficulties. And the two images at the bottom of the screen demonstrate how these students in particular used it. These were students who had dyslexia and they were in their first and second years of engineering degrees. And they found that they made a lot of mistakes when they were writing notes. They made a lot of mistakes when they were doing mathematics and experiments and going through the mathematical problems. And they also, one of them in particular, had problems with working in group work and communicating his ideas and getting across his concept because he was a very visual thinker. And they made a huge use of the coloured pens, highlighting and drawing within their notes. One of them said it was like having his pencil case just all together on the computer. He didn't have to carry all his felt tip pens around with him anymore. They also really liked that they could edit their notes and change their notes. And those things now seem more natural with tablet and phone devices. But one of the great things with OneNote and similar note-taking apps is they synchronize your notes across different platforms. So it means that whatever you've taken in the classroom environment, you can take those notes out with you into the field. If you're in an experiment, you can take a photograph and that can be placed into your notes, and that makes it much easier to go back and find that information. So a few of the things also built into OneNote as well is there is an equation tool, so you can write in equations into it. The Office Lens app that I mentioned allows you to take a photograph and send it directly into OneNote, so it will put it into your notes for you. It will also take photographs and put it into a Word document where it will do OCR, or it will send it to PDF if you want to print it. So it's a neat little app if you want to look for something for capturing information. You can also clip web pages and send them directly to OneNote, so again a really good researching and approach. And Microsoft have started to put some assistive tools into it. Now, there's a bit of a note of caution here because they say there is text-to-speech built into OneNote. There is text-to-speach using the voice on your computer, but it's not necessarily a high-quality voice if you're just using the Microsoft voices that are in the computer. And that does, they also have an immersive reading environment, and this is a screenshot here of the dark screenshot on the screen at the moment, and that presents the text as a sort of clear view, taking away all distractions. That's very good for focusing for those students who are distracted who need some help with interacting with text. But we have to remember that in a science and technology situation, we're often looking for images and other information, and all that gets lost in that immersive reading view. But one final thing to point out, you can also add in organizational support, so you can add in reminders within OneNote and many things like that. Now, not everybody's a fan of Microsoft, and obviously there's other platforms available, but many of those features are also available in alternative platforms. There's Evernote, which has been popular and around for a long time. That is platform independent. The only thing to note with Evernote is the free package does have quite strict limitations in how much material you can upload every month, and you have to be online in order to access your notes. So some people like Evernote, but you've got to be aware of those restrictions. Google have a note-taking app called Google Keep, so particularly for people on Android devices, that's very useful. And I also like to point out to people a good project management tool called Trello, which is like a to-do list, a board for people particularly who like moving around objects. You can sort your post-it note type notes on screen and organize them and sort them. And Trello is actually used by many corporations and companies and software development tools. So it's a really good project management tool that if students start to use, they can use it in their professional life as well. So moving on, it's also very useful in science and engineering to use audio with note-taking, and there's a few notes here on note-taking apps that you can use to sync audio. Evernote that I've just mentioned, Audio Note Taker, Audio Notes, they're all very good where you can write and have audio synced at the same time. For those of you who download the slides after the presentation today, there's a link here to a YouTube video that was done by JISC a few years ago, which interviews an engineering student and talks about how they use their LiveScribe pen, and it talks gives some really good examples of how it can be used for revision and going back through their notes. And just wanted to highlight a few comments from students. At Southampton, we have ongoing projects where we talk to students and get their feedback about technology, and I think these few were really telling on how they interact with technology for their writing. The tablet was invaluable in the field as it allowed me to take notes and complete spreadsheets of field results. I managed okay typing one-handed. I think the key thing with STEM is really to get a way of removing barriers as much as possible, and using photographs and images and capturing information as quickly as possible onto technology can often remove that possibility of students who have difficulty with writing getting left behind or making mistakes as they go through. The other thing is often, this is really a point for those who are delivering lab experiments and lab environments. There's often an expectation that students will use a lab book still, and there's a lovely image there of a lab experiment. You know, they think this is the way you have to do labs, but many of these note-taking apps and information collating apps can be used to gather the same information. Often labs involve group work, and instruction without formal notes or presentations. So that's a sort of critical area where students can really fall down, miss instructions. So getting your students to work together and make sure that they're working in successful teams that can work to their strengths, but also use technology as an alternative to the good old-fashioned lab books. So practical issues there, time management and organisation is really critical within those lab environments, and accurate recording and writing speed as well can be an issue. So think about how students work during the session. Can they use a photograph to capture their work, their experiment setups? Can they use video to record their results? Alternatives like that can be really useful. So encourage students to discuss with teaching staff. Make sure you understand what the assessment criteria are. We've recently completed a project with the Institute of Physics where we've been visiting university departments, and it's quite different about how people assess lab and science experiments. It can be during the experiment phase, or it can be a written up report afterwards. So students need to understand where they are allowed adjustments, where they can find extra time and such. Also, the use of templates or mind maps to structure reports can be really useful. I'll show you an example of that. Here's one from MindView, which is a mind mapping program. Many of the mind mapping programs come with templates, and this one shows how you can set out a template for an experiment so people can see how they can fill in the sections they need and capture their notes directly into a mind map, which many of them find more easy to access. So moving on, one of the critical areas with STEM is actually reading and access information in terms of that science material and mathematical material in particular. And typical science and maths resources aren't linear. They are always got quite a lot of structure and spatial information provided. In the top right-hand corner, this is a screenshot from a revision guide. As you can see, there are images and colour used quite a lot to actually indicate content. In the bottom left-hand corner, this is revision notes for electronics and physics. Again, we start to get mathematical symbols and diagrams in there as well. And we always have to be aware of what do we actually mean by accessible. PDFs can cause lots of problems, and I know there's been other webinars about those, so I'm just going to move on as we're aware of time. But when we are talking about making sure that materials are accessible and can be read, one of the things we have to think about is what do we actually mean by an accessible science STEM document. And we have to think about how it would be read aloud by text-to-speech and how that images can be described. Most electronic maths material is still represented as images. Most of it is also distributed as PDFs. And PDFs at the moment cannot provide accessible maths. And there's a screenshot here of what happens when you select maths and send it to the clipboard. Which is what many people use for using free text-to-speech programs, and the green text at the bottom is what is read aloud, which is simplify A 10.5, B 5.3, C 23.5.3+, which has no relationship at all to what the mathematics is shown on the screen. So PDFs are a real problem when it comes to providing accessible math content. There are markup solutions for maths, which means those are computer readable mathematical presentation approaches. MathML is a version of HTML that was developed for maths, and LaTeX or LaTeX is a common markup that's used by mathematical and science professionals. And with LaTeX, you just write a short bit of code, such as here, and on screen you get a representation of the equation. MathJax is used to render MathML or LaTeX on the web, and it can have built-in speech. And it can now work with some assistive technology. So if you are looking to create online learning materials for STEM, make sure you are presenting your maths equations using either LaTeX or MathML, because then assistive technologies can read that math appropriately. If you're thinking about handouts and materials, giving people electronic reading material, again, PDFs often created from LaTeX are not usually accessible, but the University of Bath have done some work in this area, and they have published a guide of how they convert their LaTeX files into accessible Word documents. So again, if you've got access to the PowerPoint at the end, you can go to those links. If you are using PowerPoint, you can create maths notation using MathType, which is a commercial add-on, an extension to the equation editor, or you can use the built-in equation editor too. So if you've got an option of providing a PowerPoint file or a PDF, always try to provide the PowerPoint file, because at least we can get the maths back out, and that can be converted into an accessible format. Microsoft Word equation editor is sufficient for most maths up to final year maths, physics and engineering degrees. And recently Microsoft Word, they've done some work on this built-in screen reader to Windows Narrator, which allows it to read aloud the equations that are created with their built-in equation editor. So we are starting to see improvements in how you can read aloud equations. Again, it's just important that you're using equation editor tools instead of images. And a recent activity from the Institute of Physics is a database with the link on here, which will provide information and links to resources about how to create accessible resources and good assistive technology solutions for students with print impairment, so particularly visually impairment, as well as those with more learning differences, to the solutions they can have to help them with reading maths. We did a project finished last year, which was looking at text-to-speech for maths, called STEM Reader, and you can go to stemreader.org.uk and download the beta. It's a free program where you can copy Word equations or MathML or LaTeX, and it will read aloud the maths to you with highlighting, and it will also present it as a visual diagram showing you the structure of the equation as well. Some people look at how are they going to go from print documents and materials, such as textbooks, to an accessible format. There is an OCR program specifically for maths called Immersive Reading. It's very expensive, and it does require quite specialist knowledge, particularly to edit and proofread the content. And American universities who use it successfully and frequently, where they're converting a high number of materials, say that it takes about 80% of the way, and then you have to do some work still after that to edit and recreate the equations. We're also starting to see photo recognition improving. There's an app that's got quite a lot of attention in the press called PhotoMath, which is available for Android and Google. You can hover over a maths equation and it will try and solve it for you. So both handwritten and printed, looking mainly at school level maths. So that's something that you might want to play around with and suggest to some students who are struggling with their maths. One of the big problems we have is actually about writing maths. As I mentioned, LaTeX is the most common form of entering maths at university level, but there is a similar keyboard shortcut solution for Word, and there is a web address here to a guide with all the different shortcuts for entering it to Word. And for those who get experience with it, you can type quite quickly and enter equations. It's still slower though than entering normal text. TextHelp recently have added on a solution for their Google Docs. It's still very early days, but again, you can add in LaTeX and create accessible accessible equations within Google Docs for those who are working within the Google frameworks. And when we're looking at exam solutions and looking at people who may be using WordPad or very basic word processors, there is an open source free equation editor from Mathcast, and that allows you to create an equation and then copy and paste it as an image or as LaTeX or HTML into other sources. Speech recognition for maths is something that has been developed in the past. There's a program called MathTalk that allows you to work with Dragon to dictate equations, but it does take a lot of work to train, and really it's only a route that you should take for somebody who is going to have to rely on speech recognition, and it's somebody who's got a good idea of the vocabulary that needs to be spoken to dictate maths, such as the Greek alphabet, all the different symbols, because all of that has to be spoken very clearly and accurately. We're starting to see handwriting recognition improve for maths. There's a few apps, particularly MyScribe, who do a lot of work in handwriting recognition. They have an app called MathPad for iOS that allows you to write your equations. It's still slower than general handwriting recognition, and you do have to be quite accurate and quite systematic in how you form letters and shapes. One of the issues we find is things like the order that you write the strokes in within the maths notation affects the recognition, so that does require some people getting into good habits and getting rid of sloppy notation. I get asked quite a lot about spelling strategies, and what I always say now is Google can spell better than anybody else, and particularly one of the problems with science and medicine fields is there's lots of specialist terminology which isn't in standard spell checkers and it isn't in standard dictionaries. So often actually now being able to search for those words on the web will be much quicker and easier than when it's flagged as potential misspells within a spell checker. So there's a meteorology example for you. Stratosphere was always the one I struggled with when I was at university. And finally, we need to think about accessible diagrams. Colour is used a lot throughout scientific diagrams and scientific qualifications. And for that, we should always follow accessibility guidelines for contrast, that make sure that there is sufficient contrast between colours. Where possible, use labels with colours. And the Institute of Physics have recently published a guidance on supporting students with science, technology, engineering and maths with colour vision deficiency. And there are also colour naming apps such as Colour ID Free, which you can use to hover over images and it will name the colour for you. So particularly if you're dealing with print resources and you've got students who are struggling with colourblind, then that can help as well. And then finally, accessible diagrams such as graphs and charts, and the use of diagrams throughout science. We need to think about how those are accessed with visual impairments. And there are a few resources. One of them is UCAF, which is the UK Alternative and Accessible Formats Organisation. They have some guidance on how you should create and describe accessible images. And then there is also a US organisation called the Diagram Centre, which provides training materials and guidance on how to describe diagrams as well. And I've just put up here a couple of examples of diagrams that are quite common within GCSE and school level mathematics and physics that engineering and students like that will have to be familiar with. And you can just see there some of the complexity that might have to be dealt with if you are having to support students with more complex visual impairment needs as well. And for those who are thinking beyond just audio descriptions, then there are now also developments with 3D printing and tactile printing where we can start to create models and materials for the students. But that's still, again, quite an area that's still not really been embraced within the UK educational system, and the Diagram Centre in the US is doing a lot of research work over there. So those of you who are interested in tactile materials and 3D materials for supporting science education, that's a good place to look. I'm aware that I rushed through that very quickly because of time limitations, just half an hour. I hope that's given you a really good feel of some of the areas you can support your students who are working in STEM fields. And if there are any questions that people have, please feel free to put them into the chat pane.